Hi everyone, so this is our second lesson. We're going to be talking about trig, exponentials, and logarithmic functions. So this is from the other day. It's very similar to the problem I gave you on, was it Tuesday? So pause the video and do the do now. Alright, so our domain, why do I have yellow? That's awkward to see. Alright, so our inside has to be greater than 0. So -4, 4. If I plug in 0, I get a negative. If I plug in 5, a positive. -5, a positive. All right, so our domain is -infinity to -4 and 4 to infinity, not equal to 0 since it's in the denominator. The range, I talked about this the other day. So if you remember, if you ignore the 16, you have -2x over the absolute value of x. So it's going to be, and they basically cancel, so it's -2 to 2. So it's -infinity to -2, and then 2 to infinity. Doop. Domain here, all real numbers except x equals plus or minus 3. And the range, when there's an x in the numerator, it's all real numbers. And you can use your calculator to check that. All right, so pause the video, domain and range of all of these. So trig, exponential, log. All right, so all trig functions have have a domain of all real numbers. That's a lie. Sine, cosine have a domain of all real numbers. The range, so a normally is -1 to 1, because it looks like that, or well, that's a cosine. This one has a shift, so the cosine is shifted down 4, so we're down 4, but then it's going to go up 2 and down 2 in both directions, so -2 plus 2 in both directions. So it's from -6 to -2. Tan. So this one is all real numbers except x equal to. So tangent is sine over cosine. Wow. So where is cosine equal to 0? So that's pi over 2. 3 pi over 2. So every pi over 2 plus pi k, where k is an integer. And your range is all real numbers. All right, so tan looks like zoop. You have to say zoop when you draw it. It's a rule, guys. All right, domain, again, all real numbers. All right, so an exponential looks like this. So it's all real numbers. For the range, you'll never get a negative because a negative exponent drops you into the denominator, doesn't make it negative. So it's 0 to infinity. All right, so log is an inverse of an exponential. So a log, the inside has to be greater than or equal to 0. Greater than 0, not equal to. So it's -4 to infinity. Your range is all real numbers. So it's kind of like the opposite of number 4. A log function looks like this. So only positives, but the range goes all real numbers, -infinity to infinity. All right, this one, same idea, 0 to infinity, not equal to. The range, so since this, it's just all real numbers. It doesn't matter that it's negative. And you can just check these on your calculator. It's good to know, the general, you should know that that's what a log looks like. You should know that's what an exponential looks like. Do we have to get into it as much as we did in Algebra 2? Absolutely not, but we need to have the basic idea. All right, solve for x. Bunch of ways to do these. 4 and 8 are multiples of 2, so 4 is 2 squared, so 2 squared times 2x minus 1 equals 8 is 2 to the third. Now that the bases are the same, the exponents are the same. So 4x minus 2 equals 3x plus 9. So x equals 11. I'm going to rewrite these so they both have an e. So e to the negative x squared equals. So this is e to the 2x, right? Those multiply. And this is e to the negative third. When you multiply, you add your exponents. So e to the negative x squared equals e to the 2x minus 3. You can think of this as either setting the exponents equal to each other, or you're going to take the ln of both sides, however you want to think about it. I think of it as setting my exponents equal. It's a quadratic, so bring that x squared over. Factor. And solve. Now, do I have to eliminate is the question. Did I eliminate one? No, with exponentials, you're allowed to have negative answers. All right, these are the more complicated ones. There's a couple ways to do these. If we want a decimal answer, you need to use, I guess you could just use log or ln. I use ln a lot. This one actually, we could do log base 10. Because if you do log base 10 of 10 to the 2x equals log base 10 of 50. Log base 10 of 10 cancels out, so this goes away, and you're just left with 2x equals log base 10 of 50, and divide by 2. Oops. I'm so used to ln. And then if you want to put that in the calculator, let's see what we get. Log of 50 divided by 2. And you get 0.849. Always give me 3 decimals. That's a set thing. 3 decimals rounded correctly. All right, so now I'm going to divide by the 8. You want to isolate your exponential. So now you have a couple options. If we don't care about the decimal, we can just do log base 3 of both sides. So in that case, x equals log base 3 of 5 over 8. The problem is the calculator doesn't do that for you. I think some of the nicer ones do, but I don't have that calculator. So what I usually do is I take the ln on both sides up here, and then that x can come down front. So I get x ln of 3 equals ln of 5 over 8, and then I just divide by ln of 3. And then I just put that in my calculator. Let's see what that decimal is. ln, and you could do log too. I just always do ln automatically. ln of 3 negative 0.428 is the answer. All right, these are easier. All right, so just like the inverse of 3 to something is the log, so the inverse of log base 3 is a 3, where the 3 is the base. So 3 log 3 cancels out. 4x minus 7 equals 3 squared. So 4x equals 16, x equals 4. Inverse of log base x is x, where the x is the base. 64 equals x squared. X equals 8. It cannot equal negative. You can't have a negative base. All right, this one. So this is using one of our log rules. So remember, what can we do with that 2? That can become an exponent. So ln of x squared equals ln of 9. E both sides. X squared equals 9, so x equals 3. Again, you can't have a negative. All right, so now the last one is actually not solvable. Oh, I mean, maybe it is. I'm sure there's a way to do it. I have no idea what it is. What I did was I put it in the calculator. So I put y equals e to the x plus ln of x in the calculator. And then y equals 4, and I found where they intersected. And I got x equals 1.315. I have no idea how to do that without a calculator. Again, there might be a way. I'm not really sure what it is. But that's what I did. All right, so now we're on to trig. So I'm assuming that we are between 0 and 2 pi. It's way too much work to do like infinite answers. So assume 0 to 2 pi. All right, that's what I'm doing. Because in calculus, we don't really do anything other than that. Remember, we are always in radians. Radians. All right. So when is sine equal to root 3 over 2? That is 60 degrees, which is pi over 3. And remember, all students take calculus. So we are in quadrant 1 and quadrant 2. So if I put that into quadrant 2, I get 2 pi over 3. All right. Root 2 over 2, that's pi over 4. But pi over 4 in quadrant 3 and 4. So quadrant 3, that's pi plus pi over 4, which is 3 pi over 4. Just kidding. Pi plus pi over 4 is 5 pi over 4. And 2 pi minus is 7 pi over 4. Right? Yeah. Sorry, I looked at my answer and it looked different. All right, so when is tangent equal to -1? So that's also pi over 4, but we are in quadrant 2 and quadrant 4. So the quadrant 4 one is 7 pi over 4 again. That's a terrible arrow. Quadrant 2 is pi minus pi over 4, which is 3 pi over 4. All right, next one. We have tan minus 1. So inverse tan, tan of pi over 5. Remember, the inverse and a function, they undo each other. So you just get pi over 5. 13 is a little tricky. So here's, when you have an inverse, think of it as tan of theta equals 2, or 2 over 1. I'm not really sure how Mrs. Blodgett teaches this, but what I do, tan is opposite over adjacent. If I do Pythagorean theorem, 2 squared plus 1 squared is 5. So this is the square root of 5. So now, so this is tan of theta, right? This is theta, right? Because tan of theta equals 2. So then what would be secant of theta? Secant is the reciprocal of cosine. So secant of theta, normally it would be 1 over root 5. This is just root 5 over 1. All right, next one. Inverse sine cosine of pi over 3 is 1/2. When is sine equal to 1/2? That is pi over 6. All right, last slide. So this one is, we're factoring, right? Because we have a squared. When I teach this, I usually have students turn it into quadratic and factor it. So 2a, minus 1 minus 3. That's the slide method. So then we have sine of x equals 1. Sine of x equals 3 over 2. Sine will never equal 3 over 2. But sine equals 1 at pi over 2. Last one. All right, so now this is a tricky one. Secant squared plus tan x. So there's a relationship between these. I'm going to tell you, I don't have it memorized, the Pythagorean identity that has secant and tan in it. So I always just figure out what it is. I have to divide by cosine. So I have tan squared plus 1 equals secant squared. So I'm going to replace secant squared with tan squared plus 1. So tan squared x plus 1 plus tan x. So that's a squared plus a plus 1.
Did you take all the calculations?
All right, this is not factorable. If you try to factor it, you can't. So we do quadratic formula. -1 plus or minus the square root 1 minus 4ac all over 2a. So we get the square root of -3 over 2. So this has no solution. All that work, and it's no solution. And I checked the book. Oh well. All right, so that is our review of exponentials and trig. I know it went fast, but I just kind of want to get through this, get those basic skills down, reinvigorate our brains so that we are ready for calculus. All right, email me if you have questions. I'll see you guys later.